In this video, we want to talk about understanding the idea of scientific notation. We want to talk about understanding the idea here of scientific notation. Now, scientific notation, when you first see it, can be a little bit confusing, but it's really pretty straightforward as long as you just kind of understand a few basic ideas. Scientific notation is used to deal with some really big numbers, maybe numbers much, much bigger than 58,000, and some really, really small numbers. The idea in scientific notation is we take our decimal point, now 58,000 has one at the end there, and we move it so that there's only one non-zero digit to the left. You can only have one non-zero digit to the left. And then we count how many places we moved it. So then we're going to write that down. That's 4 places. And so we're going to write our answer down as 5.8. And then we have to do a multiplication so that the answer is the same. Now 5.8 is much smaller than 58,000. So we're going to multiply that by 10 to the 4th power to move it 4 places. And so 58,000 is equal to 5.8 times 10 to the 4th power, or reading it properly, 5 8/10 times 10 to the 4th power. Now we also use it for very, very small numbers. Numbers that are much, much smaller than 0, like this one here, 0.000273, or reading it properly, 273 millionths, because our places are tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So 273 millionths. And so the idea is still the same. Move the decimal point so there's one non-zero digit. That would be moving it so that we have the 2 there. And that would make that 4 places again if we count. And then we would write that down as 2.73. Now 2.73 is way, way, way bigger than the number we started with. So we need to make it smaller. So what we do here is we multiply by 10 to the negative 4th, because what we really need to do is actually divide by 10 4 times to fix it. But we can use our negative exponents here to deal with it. And this is one of the few times that we like to keep the answer with a negative exponent. So scientific notation allows for the exponents to be negative. In fact, the negative exponent in scientific notation means it's going to be much smaller than the number you have, whereas the positive power means it's going to be much bigger. So I know some people talk about left, right, always kind of get a little confused, think you can easily get confused with left to right, get them backwards. But positive power, move it to make it bigger. Negative power, move it to make it smaller. Or if you're going this way, if it was small, it's going to have a negative exponent in scientific notation. If it was really, really big, then it's going to have a positive exponent when it's in scientific notation. So now that we understand a little bit about what scientific notation is, we're going to look at a couple of examples going to scientific notation and from scientific notation. So we're asked here to write the given numbers in scientific notation. So we're asked to write here in scientific notation. So here we take first our number 0.000072, or 72 millionths. So again, the idea is move the decimal point so that you have one non-zero digit, count up how many places we moved it. In this case, that would be 5 places. So we'd write it down as 7.2. Since it was a small number, that's going to be 10 to the negative 5th power. 10 to the negative 5th power. As another example, consider the number here, 15,800,000,000. Again, take the decimal point, move it so that there's only one non-zero digit, in this case the 1. We can then write it down as 1.58 times 10, and then we count how many places. In this case, it would be 3, 6, 9, 10 places. And that was a big number, so that'll be a positive exponent. 1.58, or 1 in 58 hundredths, times 10 raised to the 10th power. Okay? Let's go the other way now. Sometimes they'll say write as a decimal, or, as I said here, write in standard form. So here we're going to be given a number in scientific notation, and our job is to go the other way. Our job is to go the other way. So here I have 4.63, or 4 63/100ths, times 10 to the 12th power. So remember, scientific notation, that 10 to the 12th, that's going to make this a really big number. So we have to move the decimal point 12 places to make it really, really big. So that would be 4, 6, 3, took care of 2 of the places, and then I need 10 more. And so in the end, I'm going to have 463 followed by 10 zeros, followed by 10 zeros. So that's actually going to be 4,630,000,000,000 if we read that number off. Consider this example, 6.429, or 6 429 thousandths, times 10 to the negative third. Here it's a negative exponent in scientific notation, so we need to move it 3 places to make it smaller. The first place is going to put the decimal point in front of the 6, and then we need 2 more. So that's going to be 0.006429. 6429. Okay? And so now we put each of these numbers from scientific notation into regular notation, or vice versa. One final little note, a lot of times on a calculator, it may spit an answer out like this. That means 1.3 times 10 to the negative second. If you ever see that, your calculator spit something out like that. So sometimes you're going to see calculators do things like that. They have their own way of displaying stuff in scientific notation. But as long as you just kind of remember to keep track, positive exponents mean it was a big number, negative exponents mean it was a small number, and then the exponents just telling us how many places to move it, you should be able to keep scientific notation pretty straight.